Hey everybody, Bill Sky, the assembly guy here, and what we're going to do today is that we're going to continue our conditional branching video, but this time what we're going to do is we're going to take if statements that you might find in Java or C or C++, specifically the last two, and we're going to implement those in assembler just as if the compiler was actually doing it into machine code. Some compilers actually generate code in assembler and then let the assembler take care of it, but in this case, what we're going to do is we're going to act like the compiler, and we're going to take an if statement that we might have created in one of those languages and convert it into assembler language. So let's get going. All right, I've got a Linux up here and running. Now this is exactly the same way it would be in Windows, so we don't have to do it on Windows if we don't want to. You can do it in Windows. You have my blessing like you need it. And I've got a 64-bit assembler language program right here, so let's go ahead and edit that, and let's go ahead and let's first of all create some variables. So I'm going to go ahead and I'm going to create a variable called A. I'm going to make it a quad, give it a value of 10. Variable B, make it a quad, give it 20. Some more here, and we're just doing this to get some data variables out there for our if statements. Now you could do this with literals, but it's kind of a waste of time to do that. So let's actually do it with some real memory variables, and let's see how this will work. Okay, so I created 4 variables, all quad words: var A, var B, var C, var D. I gave var A 10, then 20, then 30, and then 0 in var D. So the way I'm going to do this today is I am going to write the if statement sitting right here in comments, and then we're going to go ahead and implement it in assembler how you would do it, or how the compiler would do it. So my first if statement is going to be a simple equality test, and let's do this as signed. We need to have practice in both signed and unsigned. So we're going to say if var A is equal to var B. Now some of these if statements are going to be really stupid, but we're mainly doing it just to get the feeling for how you would do this. And then I'm going to say if they're equal, I'm going to say var C is equal to 22, else var C is equal to negative 22. So how do we actually implement this? Well, what you can do is you can just start comparing right away, but then what I have seen in my experience, if you just start doing compares and jumps, you're going to have many more jumps. You're going to have at least one more jump than you need. So what I like to do is I like to assume that one of these situations is actually true. I want to assume that var A is equal to var B. So by doing that, I'm going to move into RCX the value 22. So I'm going to assume that this is true. So this way you're going to eliminate a jump, and you're just not going to need it. So your code's going to be a little bit more efficient. So let's assume that var A is equal to var B, and let's just assign 22 to RCX. Now the reason we're putting it into RCX is that you do your comparisons within the CPU, within registers. So let's make RCX our destination register. All right, so now let's go ahead and move into RAX var A. Let's move into RBX var B. And now let's do the compare. Compare RAX with RBX. Now RAX is going to contain var A, so we're doing that if statement on line 31. We're going to compare is RAX equal to var RBX, which is var A equal to var B. So jump if they're equal to if else one end. It's just some label I'm creating. So if they're equal, I've already done the assignment, so I don't have to do anything else. I just leave the if statement. Otherwise, if they're not equal, I'm going to move into RCX negative 22. Here's my label. And then I'm going to move into the destination register RCX. So there you go. So we're going to assume var A is equal to var B. Move our data into the registers. Do the if equal. We already did the assignment. so leave the if, not equal, so assign -22, store the result. Comments are so important. Now, how would we have done this without assuming? Well, I'm going to copy this, and this is a good exercise. So I'm going to copy this, and I'm not going to assume anything. So I'm going to compare RAX and RBX. If they're equal, I'm going to jump to this end, but now what I have to do is that I have to move into RCX 22. If they are not equal, I move -22, and then I have to jump around this. So jump, let's just call it something 1. And then I have to put something 1 here. And then I have to jump around this. Now there might be a better way of doing this. Well, actually, do I need to do that? Jump to something? No, we're okay. So you add 1 or 2 extra lines if you don't do the assumption. So I think this is a lot more sophisticated code than this is. However, this might work just fine. But I just like doing it this way, just to make an assumption, then you don't have as many jumps. Now another thing you might think is, why can't we just compare the data while it's out in memory? Well, the instruction may not even allow you to do that, but it doesn't matter, because you've got to go out to memory to go get the data anyway and put it in a register. And that's what the CPU is doing underneath the covers anyway. It's going out to get the data, doing the comparison, and then putting the data out there. So it doesn't matter either way. This is a little bit ARM-like, is that you move all the data into registers and then you do the work. That's not a bad idea to do that. So let's go ahead and save and build that. And it built just fine. So go ahead and debug it. I'm going to leave it up to you to debug, try it out, and let's move on to the next one. So the next if statement I want to do is a complex, what I like to call complex if statement. I'm going to call this a complex and equality test. And let's do this assigned as well. And what this is going to do is I'm going to ask if var A is equal to var B and var A is greater than var C. How would you implement this? And let's go ahead and say var D will be equal to 33, else var D is equal to -31. So a pretty simple little if statement, but how would you do an AND? Well, one thing to remember, and we talked about this in logical operators, the AND means that for var D to be given the value of 33, both of these have to be true. So there's a little trick here. If you find out that the first one is not true, why even bother doing the second one? There's no reason to even bother doing the second one. Or if you find that this one is true, you must make sure that this one is true as well. So you can kind of, I mean, there's no assumption, but you check one. If it's false, leave the if statement. Don't even bother doing the second one. So this one's going to be a little bit different than the simple one. What I'm going to do is I'm going to move all 3 of those values into my registers. So I'm going to move into RAX, var A. I'm going to move into RBX, var B. I'm going to move into RCX, var C. Now what I'm going to do is I'm going to assume that the result is going to be false, that either one of those are not true. So I'm going to move into RDX, which will be our result register. I'm going to move -31 into there. I'm going to compare RAX and RBX. Now we're comparing var A and var B. I'm going to say jump if not equal to if else to end. So if var A and var B are not equal, why even do this? Let's just jump out of the if statement completely, and let's put that label here. So just jump out. The first ones aren't equal, so don't bother. We've already set it to negative 31. Nothing more to do. All right. So, but if they are equal, then what I'm going to do is I'm going to compare RAX and RCX. So I want to see if var A, because RAX contains var A, RCX contains var C, I'm going to compare those, and I'm going to say jump if less than or equal to, if else to end. Now remember, the opposite of greater than is less than or equal to. And also remember, this is signed, so we're not using above or below, we're using less than or greater than, because that's what signed does. Unsigned uses above or below. So if it's less than or equal to, which means this is not true, then we're going to jump to the end because we already did this assignment. Now, if that's not the case, we're going to move into RDX 33, which is the true condition because both of these are true. And then we're going to move into var D RDX. So I'm going to leave it to you to put the comments in there, but I really recommend that you put the comments in there. You save this code, you've got it in your database or your files of sample code, and you can understand why you did things the way you did them. All right, so now let's try an OR. So that's an AND. Let's go ahead and try an OR. So I'm going to call this one complex OR equality test. And let's do this one unsigned. We need some practice doing things unsigned. And what I'm going to do is I'm going to use RCX as the temporary register. And you could have actually, you probably should have in your comments here, we're going to use RDX as our temporary register. Now in these ifs, you're not modifying any of the data until you get to the very end. So just that's a little piece of information there. All right, so how are we going to do this if statement? I'm going to say if var A is less than var B, or var A is less than var C. Now this is another situation where it's a little bit of a trick. If either one of these are true, if either one of them are true, then that means that both of them are true. Well, I shouldn't say it that way. If either one of them are true, that means the result is true. So, and that's because it's an OR. So let's go ahead and say, what are we going to do here? I'm going to say var D is equal to var A. Else, we're just finishing our if, var D is equal to var C. So there's our if statement. So how are we going to set this up? So let's move everything into the registers first. I'm going to move into RAX, var A. I'm going to move into RBX, var B. I'm going to move into RCX, var C. All right. Now, now it says here that we're going to use RCX as a temporary. I think I shouldn't have done that. We're going to use var D because we actually have 1, 2, 3 variables we have to check. And for some reason, it's A, B, C, D is how I do things. So RAX, RBX, RCX, and then RDX is going to be our temporary. So what I'm going to do is I'm going to assume that the result of this is going to be true. I'm always making an assumption when I write this code. So I'm going to move into RDX, and I could do it this way, var A. Now, this is not what I call efficient code, because every time you access memory, even though it might be in the cache of the CPU already, because we did the move up here, this is not really efficient code because it takes longer to get the data out of memory than it does just to get it from a register. So instead of doing this again, this time into RDX, we already did it into RAX, how about just copying it from RAX? So that means you're not going out to memory, you're not grabbing that memory, and it's just more efficient. So that's why we're doing that. All right. So let's go ahead and compare RAX, RBX. Now remember, this line of code is assuming that one of these two are true. So it's doing this assignment, and remember we're using RDX as the temporary register. So let's compare RAX and RBX. If RAX is below, remember this is unsigned, so if RBX is below if RAX is below RBX, if var A is below var B, we're going to jump to the if else 3end. That's a label I haven't created yet, so let's create it. So if RAX is less than RBX, which is var A less than var B, we've already done the move into RDX of var A, so we're just going to leave the if. And then let's go ahead and move into var D, RDX, because RDX is our temporary register. So if this one is true, just leave the if. Don't bother asking the other question. But now we have to compare RAX and RCX, which is var A and var D, if this is not true. So we're going to say compare RAX and RCX. Jump if below, so if var A is less than var C, jump if below if else 3. So we're going to jump down here again because we've already done this move right there. Otherwise, move into RDX, RCX, because RCX contains var C, and that's what we do in the second half of this if, and then we've already gone ahead and done that. So pretty cool is that we've got these three different if statements. We've got a simple equality check, and we've got a if statement here with an and an if statement here with an or. I strongly recommend that you put some if statement, or not if statements, you put some comments in here, because you're going to get up, you're going to go to lunch, you're going to go to dinner, you're going to look back at this code and you're going to say, I have no idea what this was doing, if you don't have comments. So I really suggest that you get some comments in there. Now, just for completeness, I want to show you another way you could have done this. Instead of moving all of the data into the registers, what you could do is you could have compared the variables or the memory directly. And let's look at that. So I'm going to compare, and this is just some dummy code. I'm going to compare var A with var B. Now, first of all, that is not legal. You can't do that in x86 64 Intel assembler. You can't compare two variables directly like that. And I believe mainly it's because it doesn't know how big it is. It doesn't know if var A is a quad word. It doesn't know if you're wanting to do it as a byte. I could maybe put Q word there. Let's see if that builds. It still doesn't build. And that's because the operation is just not legal in x86 64 assembler. So what you could do is you could, let's move into RAX, var A, and then let's compare RAX with var B. So, okay, it looks like your code's a little bit less. I guess what you could have done is you could have done this compare down here like this, but what's actually happening behind the scenes? Well, the CPU has to send out an address request to the memory chips saying that I want var B. The memory chips then tell the CPU, okay, I'm ready to send you var B. Then the CPU has to tell the memory chips, do it. Then the memory chips have to send the data over the data bus back to the CPU, and then the CPU does the compare. So why go through all of that, right, on the compare? Since you're going to need RAX again, because you're comparing RAX up there, you're comparing RAX there. Now, it could be argued that you're only comparing RBX once, so, why use up a register? Well, why not? Because you've got to go get the memory anyway. It doesn't really matter. I don't think the speed is going to be any better, in this case. However, if you have to go out and get var B multiple times, this wouldn't be the case, but if you do have to go get it multiple times, that could actually affect performance. So that's something you have to think about when you're writing these if statements. what is the most efficient way of doing it. And number one, assuming that a condition is true or false before you actually start doing compares is the first way you can improve performance. The second way is get all the data into registers. Now, it could be that you've got such a large if statement that you can't do that and you'll be forced to. So let's say if you had an if statement, something like if var A equals var B and var A is greater than var C and var C is greater than var D and var D is greater than var E. I mean, if you've got something really complicated like that, how would you do that? Well, the assumption still works. If the first condition is false, then forget about all the other ones. So that logic still works. However, if you've got to move var A into a register, var B into a register, so if you did something like this, move into RAX var A, move into RBX var B, move into RCX var C, move into RDX var D, and then you've got to do something with var E, move into R. There is no REX register, right? So where could you put it? Well, there's an R8, an R9. There are those registers also in 64-bit, but there's not in 32-bit. So you're kind of a little bit screwed there. So in the case of this compare of var D and var E, you could say compare RDX, and we're talking about this one right here. Compare RDX with var E. So since we're only using var E once here, this isn't that big of a deal, and we've saved a register. We don't have to go find another register to contain var E. So you've got to think of that when you're saying, okay, how am I going to do these comparisons? How am I going to get the data into the registers? And you just have to think about it a little bit. There's a little bit of design here. And as I said also, please make sure you put in your comments. I'm telling you, I told you a story before. I had a peer of mine laughing at me because I didn't put in comments, and then I took an hour or so to figure out what I was doing. Put those comments in there. You're going to be in really good shape. So there you go. There are some complex if statements using conditional branching. Hope to see you at the next video.